I will be presenting our pilot study for the textile industry, and I will talk on the environmental impacts of the textile industry and how we find solutions to mitigate the environmental problems caused by the sector. And I will show you our zero brine pilot plan and technology and process, and I will show the results. The textile industry is known its high water consumption. It's water intensive sector. The water consumption ranges depending on the product, and for example, for cotton productions, it's like 60 to 120 liters per kilogram of products, but for the wool product, it's much more higher, like 110 to 650 liters per kilogram wool. And water is used for dyeing, rinsing, and finishing operations, and they all require extensive water use. And the other important material for the textile industry is salt. Salt usage is also significant in the industry because salt is used in dyeing of cotton and linen fabrics. Salt acts as a raw and auxiliary material, but also results in salt wastewater stream. So it also creates a highly polluted brine that can have serious environmental and ecological impacts, especially for the inland receiving water bodies such as lakes and rivers, and it may cause salinization of the soil, as you know, which is one of the most severe environmental problems in agriculture. We designed a pilot plant and installed it in the company, and now still it has been under operation for some months. And the company is located in Lüleburgaz in the Marmara region of Turkey. And this is here you see our pilot system installed in Zorlu Textile Company. You see this brine blue storage tanks. The wastewater generated, the brine generated in the company is pumped into this blue storage tanks. And in this container, we have technologies to reuse to treat and reuse the skim to overview the whole process and for a better understanding. This is the textile industry where the wastewater generates. As I mentioned, it consumes lots of water for the production. So the high amount of wastewater is treated in chemical and biological treatment first, then partial, not the whole amount of the wastewater, but some of the wastewater is treated in an advanced treatment plant for the reuse purpose. And this is where the brine generates. The reverse osmosis concentrates contains high amount of salt in it, but also the impurities, because the recalcitrant or resistant organics to the degradation like dyes and colors and organics still remains in the brine together with the salt. So we developed the technology to remove these impurities, color, organics, which have recalcitrant characteristics, so it's difficult to remove them, and also the hardness and sulfate, so on, that can be to reach the quality that can be reused in the process. So after our process, the concentrate treatment and recovery system, the brine solution, the treated brine solution is reused for dyeing process in the industry. And also we produce reusable water for the process during this treatment system. The CD process that we use in our pilot system. As I mentioned in previous slides, the wastewater, this brine contains high amount of resistant organics. So we applied an oxidation process to remove the organics and color, which are important to be used in dyeing process. So by the ozonation process, you see the picture on the right-hand side, we removed 70% of chemical oxygen demand and over 95% of color. And following the ozone oxidation process, we applied nanofiltration process because still there are some residual organics and color in the wastewater, and also hardness and sulfate. So we applied nanofiltration to remove those pollutants while keeping the salt in the permeate. So in this process, in addition to the ozone oxidation, we achieved an additional 30% of organics removal, 50% of color, 50% of sulfate, and 40% of total hardness. But in this process, we lost some of salts, which is 10 to 15 and also 16% of the total dissolved solids. And after the nanofiltration process, you see the picture on the right-hand side, we use ion exchange process. Hardness is one of the most important parameter for use of the brine in dyeing process, because it affects the performance of the dyeing process and the quality of product. So hardness is an unwanted pollutant, so we remove the residual hardness by cationic resin units, so to achieve the reusable quality. And finally, we apply the reverse osmosis process for concentrating the brine. And with the reverse osmosis process, the feed's TDS concentration can be concentrated up to 4 times. You see the picture of reverse osmosis system in our pilot on the left-hand side. And this concentration is sufficient for the textile dyeing process. And in this reverse osmosis process, we also produce clean water that can be utilized for several purposes within Zorlu Textile. And what is the benefits of this study for the textile industry? Let's have a look at it. Our pilot plant capacity is 300 liters per hour of reverse osmosis for reverse osmosis retentate. So this discharge is prevented for the industry as a result of our pilot study. And the process results in 50 to 60% of recovery of sodium chloride for dyeing process. And also it's possible to reuse, it may be possible to reuse some part of the sodium chloride for the softening process. And 70 to 8% of reusable pure water stream for process is achieved. And if the process is upscaled to the full wastewater, like real size scale, it's possible to recover 400 tons of brine concentrate per year. And based on the carbon dioxide equivalent of salt and water recovery, there's a potential reduction for the emissions of carbon dioxide.